It's a question from Siyanda Tutisomis, and it reads how to calculate different time zones. Now, Siyanda, this whole lesson today is for you and all the others out there with the same question. So let's get straight to it. Guys, how to calculate time zones and how does time zones work? It's very important that we start with the building blocks again, and those building blocks are normally our definitions. So let's have a look. All right, understanding time zones. First of all, we need to understand that time zones are based on longitude lines. Our longitude lines are those lines that runs over the earth from north to south, and the space between those longitude lines is called a time zone. So you must know we have 24 hours in a clock. That's the basic principle of time that you are taught from the moment that you actually can read the time on a watch, especially a digital watch. So from 12 o'clock midnight up until the next 12 o'clock is 24 hours. So we've got 24 hours in a day. And that is very important because in time zones, when we measure time all over the world from place to place, we are only going to utilize those longitude lines, in other words, the lines that runs from north to south, and we're going to look at the space between those lines. You see, the space between every one of those 24 longitude lines is what we call a time zone. All right. Latitude lines are also very important. You'll see that we work with a very important latitude line that's called the equator. Another name for the equator is also the 0 degree line of longitude. Now, the reason why this line is so important is because it divides the Earth into a northern and a southern hemisphere. Now, we all know that if we had a little bit of geography or we watched movies before or so, but the essence why the 0 degree latitude line, in other words, running from west to east, is so important is because it helps us identify seasons. You see, later in this lesson, when we talk about daylight saving time and when we talk about summertime and wintertime, it's important to note that when it's, for example, summer in South Africa, which is in the southern hemisphere, it will be winter in the northern hemisphere. And the equator is obviously the line that divides the Earth into those two hemispheres. All right. Secondly, we need to look at the zone that I spoke about. So between every two longitude lines, there is a zone that's represented on a map or on the Earth. And that zone is exactly 1 hour apart from one another. Now, it's very simple. You see, the Earth is 360 degrees. We all know a circle is 360 degrees. The Earth is 360 degrees. Therefore, it's very simple that we divide that 360 degrees by 24 hours that we have on our clock. And the answer that we get there is it tells us that there's 15 degrees between every two longitude lines. In other words, that 1 hour and the 15 degrees is basically the same thing. So the Earth rotates around the Sun and around its own axis. And the Earth rotates from west to east. All right, guys, so basically, just to recap what I've just taught you, because it's very important, we have to build on these building blocks to be able to eventually understand time zones and also to be able to understand time zone calculations. All right, so the Earth is round. We've got a 0 degree latitude line that divides the Earth between a northern and a southern hemisphere. That indicates seasons to us later on when we go into depth. For now, you also need to understand we've got 24 hours in a day. That means we have 24 main longitude lines that we are going to use in time zone calculations. Of course, on a world map, a standard world map, you'll find a lot of longitude lines that's indicated there. In fact, all the crossing of longitude lines and latitude lines is basically how GPS coordinates work. But for time zones, we work with the 24 main longitude lines. All right, now those lines have names, and we name them by means of degrees. So I've just proved to you by dividing 360 degrees by 15, or by 24, sorry, we get a 15-degree space. So every longitude line is 15 degrees apart from one another, and 1 hour. All right, very important. We have a very, very important line of longitude that we have to work with. It's called the Universal Time Coordinate. Now, most of the time you'll see the acronym. So it's very important to know all your acronyms in tourism as well, also known as the UTC. This UTC lies on the 0-degree longitude line, also known as the Greenwich meridian time or the prime meridian. All right, guys, so basically, with time zones, you must memorize GMT, UTC, 0-degree line of longitude. Why is that so important? Because that's our departure point for all our time zone calculations. All the time in the world where we work out time differences are measured from this GMT line. Now let's see if we can literally look at everything I've explained to you just now in a figure. So basically this circle here represents the Earth because it is 360 degrees. Now with the lines that are identified on this circle, we can say, if you look there, there's the prime meridian or the 0-degree line of longitude, or we also know it as the GMT. As I've also mentioned to you, there's another line of latitude, which is that one there, and it's called the equator. This divides the Earth into a northern and a southern hemisphere, which will later help us to identify where it's summer and where it's winter. And then as you can see here, all these other lines over here are our 24 lines of longitude that runs right across the globe. They are exactly 15 degrees apart from one another, and that 15 degrees represents a 1 hour difference. All right, so basically if you want to know the name for each of these lines, you'll see here, this one is the 15-degree line west of the GMT, that one is 30 degrees west of the GMT, 45 degrees, and I can go in a full circle, basically up to this 180-degree line over here at the top. That is a line we'll discuss later on, which is known as the international date line. If we go in the easterly direction, you'll see we've got the 15-degree line east of the GMT, 30-degree line east of the GMT, and so forth, all the way up to this 180-degree line of longitude. All right, so guys, now I've shown you on a practical sketch basically what I've just explained to you in terms of how to identify your lines, what their names are, how far they are apart. What is very important to note as well is when we see the sun rise in the east every morning, it's actually a perception because the sun is still, the Earth is rotating. To be able to experience that means that the Earth is rotating from west to east. That is what is happening in reality. All right, now let's have a further look at time zones. All right, so standard world time is measured from this GMT. So we say standard world time because every place in the world have a different time. All the lines east of the GMT are ahead of standard world time, ahead of this GMT. All the lines west of the GMT, and another name I told you is the UTC, are behind of standard world time. Right, guys? So from now on, and I might upset a few maths teachers and so on, please don't tell them you were taught by Mr. Paul Els. Rather just say, teacher, I'm working with tourism now, and in tourism, a plus and a minus indicates direction. All right, so if we are at the GMT and we want to know what will the time be east of us, we're going to go forward in time. In other words, earlier, which means we're going to plus. If we want to know times west of the GMT, in other words, towards countries like the North and the South Americas, we're going to minus. That indicates direction, and that's very important. And I think that's where most of you make mistakes in your calculations later on when we work with the figures. because you plus and minus mathematically, and obviously then you confuse yourself. All right, so guys, another important fact. If we look at this picture that I have here, just a quick reference point here. If it's daylight this side of the Earth, 12 hours across from the globe, at the exact opposite time, it is midnight. So if it's 12 o'clock midday this side, it is 12 o'clock midnight on that side. All right, just to give you an idea of light and dark and how the sun works. All right, again, remember the Earth rotates from west to east. All right, now we're getting to another definition that's very important. Our 180-degree line of longitude. Remember I showed you on that picture with all the degrees, we've got the 0-degree line of longitude, which is the GMT. Standard world time is measured from that line. Now there's another important line, 12 hours across from this 0-degree line of longitude, called the 180-degree international date line, also known as the IDL. All right, IDL standing for International Date Line. Now what's important about this date line, if you look at the picture I have there, this is the back side of the globe. Obviously it's round, so there's no front or back, but in this picture, there's the 180-degree international date line. If you know your countries, you will see it will feel the opposite, because that is Australia over there, and here we have the west coast of Canada and North America. So basically what you need to understand of the international date line is that if you travel across the international date line, the date changes. For example, if we travel from Japan, which is in the east, to Canada, and this is via the Pacific Ocean, our biggest ocean on the planet, then the date will change from today to yesterday. So basically, you've time travel when you look at dates, although time traveling is not possible in my opinion. All right, so you have literally went from today to yesterday when you travel in a western direction. The opposite applies as well. The date changes from today to tomorrow's date when you travel east over this international date line. For example, from the west coast of Canada to Japan, which is in the east. Then you have literally changed the date. Now guys, some countries, like for example, the United States of America, Canada, Greenland, Russia, Australia, there's a few countries I can mention, no use in mentioning them all, have more than one time zone. Now remember I said a time zone are the space between two lines of longitude. Now some countries are so widespread that they have more than one time zone. In other words, if you travel from the eastern to the western part of that country, you will note that internationally you have to tune or set your clock or your watch to a different time because of those time zone differences. All right, so let's quickly summarize everything that I've just explained to you per definition on an actual time zone map. So guys, this is the map that you will get in most commonly any exam or proper time zone question. All right, so let's have a look. First of all, when you tackle time zones, you have to identify your time zones on your map. The first very important line that you have to identify is the 0-degree line of longitude. We said that is our GMT. All right, so you can use a highlighter, Koki, or just your pen on your time zone map in your question paper and highlight it. The second line that's very important is our equator. All right, you'll see the names are on the map, but I mean you can be creative and you can make your own shorthand and just to understand what you have highlighted there. All right, now I've mentioned to you, if you travel or you're looking for a time in the eastern direction, we're going to plus. If we need to find the time in a western direction from any given point on this map, we're going to minus. Plus is east, minus is west. All right, I've mentioned to you countries have different time zones, those countries that are very widely spread. For example, if we look here at Australia, you'll see the different time zones are indicated with light and dark colors. You see there's one time zone, for example, there's a different or another time zone, and there's another one. So Australia have 3 different time zones. In South Africa, we are lucky enough to have 1 time zone. Now, guys, how do we read time zones from a map? Because I think that's where most of us makes our mistakes. So time zones is actually very simple to read from a map. Whenever you have a question on time zones, you need to find the location that they mention in the question on your time zone map. So first you find the location on the map, and from there on you put your finger on that location, you go all the way up to the top of your time zone map, and there you will find a number. It will either say +1, +2, +10, it will say -2, -5, minus, depends on where that place is on the map. All right, let's make an example. We are in South Africa. We want to know what's the time zone of South Africa from the GMT. So we've identified South Africa. South Africa is over here. We go all the way up, and you'll see there's a line and there's a line. Those are 2 longitude lines, so the space between this line is our time zone. So if we go all the way up, you see over there South Africa, and you can say South Africa is GMT plus 2. In other words, we are 2 time zones, plus means east, from the GMT. All right, guys, so basically that is how we identify time zones on a time zone map. Now that you have all these definitions, let's just add 1 or 2 more interesting facts, and then we can move on to our calculations later. You would have heard of daylight saving time, or as we know it, DST. Now, daylight saving time are for countries located far from the equator. You see why it's important that we listed and mentioned the equator. They have short days, and the sun, this is very important, rises long before 6 a.m. in the mornings, and it sets earlier in the afternoons. So guys, these countries really need to utilize available sunlight during business hours in their summer months. The word summer is very important. So countries that do apply daylight saving time are those countries where the sun rises earlier in their summer mornings and it sets earlier. So if they will get up normal time as usual, it means they will be getting to work when the sun is sitting high already, and they will still be at work at 4 or 5 o'clock in the afternoon when it's already dark and nighttime. So to change that, we can't adapt, or we can't change the rotation of the earth or so, but we can adapt to it, and therefore they tune or set their clocks 1 hour ahead of standard world time. Ahead meaning plus. So that's very important. All right, there are definitions or words that you can familiarize yourself with. So these countries tune their clocks 1 hour. So in a calculation, whatever you do, it will be +1, or per definition, it will be 1 hour ahead of local standard time. But very important, guys, and please, this is extremely important. It's in the summertime in those countries. This is called daylight saving time, or the acronym is DST, or some countries refer to it as summertime. Now, obviously, when you've been applying daylight saving time in your summer in your country, there comes a time where you have to turn your clock back to standard world time or local time. So in order to do that, they obviously announce it on their radio stations, over TV, in newspapers, but most commonly people in those countries are kind of pretty aware of it because they've been living with that type of time changes their entire life. All right, for foreigners who go to those countries who don't know what's happening or so, there are 2 phrases that they use to say they tune their clocks for daylight saving or back to normal time. And that is what they call fallback, which is when they go back to standard time, or spring forward is when they actually set their clocks the 1 hour ahead of standard world time. All right, so why do we learn about time zones in tourism? I mean, again, this lesson feels like it's aiming in a direction of maths, and we are busy with tourism. You see, tourism consists of a lot of interesting factors, and so in this sense, we need to understand what the impact of different times in different places of the world will be when we travel. You see, you get on a plane in Cape Town and you travel to Europe. You know the flight might be 13, 14 hours long in duration, and you assume if I take my South African watch, add that flying time, the time of arrival will be what I think it will be if I get to Europe. Of course, when you get to Europe 13 hours later, that will be the time in South Africa, but not be the time in Europe, because Europe is on a different place on the earth, on the map, which means it's got a different time. And you need to work out those differences. All right, so what effect does all of this have on tourism planning? All right, if we fly to other countries, very important, we might be arriving at a different destination in the middle of the night in their local time or early in the morning, which means some public transport services might be closed or unavailable. When you travel by border posts or by road from one country to another, for example, South Africa to Botswana, you might find that you get to the border when the border is closed. So you've traveled from Europe to South Africa by plane, you traveled with a car from South Africa to Botswana, but you are stopped at the border because the roads are closed because it's in the middle of the night. Also, very important, especially for travel agents, if you phone people in other countries, it might be 9 o'clock in the morning in South Africa, and you can't figure out why people in America are not picking up the phones. It's because it's still midnight in America. All right, because of time zones. So to do business is very difficult if you don't know what the time is in another country.